Group B presents Spanning Tree Protocol. Brought to you by Poly Syrup, Polycarpio, Poly Design, your polo made in Carpio, Poly City, Night for Poly, Ice P Poly. Special thanks to Poly Movie Production.
Go.
Election process. All switches pretty much
Now the
Good day, everyone. Our group will be here to tackle all about Spanning Tree Protocol. Now, in case you were wondering, what is Spanning Tree Protocol? Now, STP ensures that there is only one logical path between all destinations on the network by intentionally blocking redundant paths that could cause a loop. The switches running STP are able to compensate for failures by dynamically unblocking the previous blocked ports and permitting traffic to traverse the alternate paths.
Here are some terminology about spanning tree algorithm. Root bridge, a single switch used as a reference for all calculations. Root ports, the switch port closest to the root bridge. Designated port, all non-root ports that are still permitted to forward traffic on the network. Non-designated ports, all ports configured to be in a blocking state to prevent loops. FTP uses the spanning tree algorithm or STA to determine which switch ports on the network need to be configured for a blocking to prevent loops. To run an election process, the algorithm designates a single switch as the root bridge and uses it as a reference point for all calculations. The election process is controlled by the bridge ID or BID.
The election process. All switches in the broadcast domain participate. After a switch boots, it sends out Bridge Protocol Data Units or BPDU frames containing the switch BID and the root ID every 2 seconds. The root ID identifies the root bridge on the network. By default, the root ID matches the local BID for all switches on the network. In other words, each switch considers itself as the root bridge when it boots. As the switch forward their BPDU frames, switches in the broadcast domain read the root ID information from the BPDU frame. If the root ID from the BPDU received is lower than the root ID on the receiving switch updates its root ID, identifying the adjacent switch as the root bridge. The switch then forwards new BPDU frames with the lower root ID to the other adjacent switches. Eventually, the switch with the lowest BID ends up being identified as the root bridge for the spanning tree instance.
best path. Now that the root bridge has been elected, the STA starts the process of determining the best paths to the root bridge from all destinations in the broadcast domain. The path information is determined by summing up the individual port costs along the path from the destination to the root bridge. The default port costs are specified by the IEEE and defined by the speed at which port operates. You are not restricted to the defaults. The cost of a path can be manually configured to specify that a specific path is the preferred path instead of allowing the STA to choose the best path. Realize, however, that changing the cost of a particular path will affect the results of a STA. The no form of the following command will return the cost to its default value.
To configure spanning tree costs, type in enable config terminal interface FA0/1 spanning tree costs, then the value. To verify the port and path costs, type in show spanning tree As you can see here, the port cost is 19. Then the path cost of both interface FA/2 and FA/1 is 19.
Hi, John here. I'm about to tell you how FTP Bridge Protocol Data Unit works. FTP determines a root bridge for the spanning tree instance by exchanging Bridge Protocol Data Unit, or what we call the BPDU.
This table shows the root bridge and the cost of the path of the root bridge. In root bridge selection process, we can see that there are three switches that are shown in the topology, which are the switch 1, switch 2, and switch 3. Here we can see that switch 2 is going to send packets to S3 and S1, while all of them has this root ID, bridge ID, and path cost. S3 believes S2 is the root bridge, while S1 still thinks it is the root bridge. Then S3 sends packets to S1 and S2. S2 and S1 both think that they are the root bridge. Then S1 is going to send packets to S3 and S2. And S3 recognizes S1 as the root, and S2 recognizes S1 as the root. If the root bridge fails, the selection process begins again.